Welcome back to my channel, students. Today I am going to discuss about some problem on a electrochemistry chapter. First, let us see some important formula comes in a electrochemistry. The first one is E0 cell is equal to E0 cathode minus E0 anode. Okay, we know that E0 cell is a standard EMF of cell. E0 cathode is a standard reduction potential of a cathode, and this is standard reduction potential of a anode. Okay, the second one is a delta G0 is equal to minus n F E0 cell. Here we know that F is 1 Faraday. The value is 96,487 coulomb per mole. So here n is number of electrons transferred by the reaction, and we know that delta G0 is a Gibbs free energy. Okay, the next one is E0 cell is equal to 0.059 by n log Kc. Here Kc is the equilibrium constant. Then E cell is equal to E0 cell minus 0.059 by n into log of product divided by reactant. Here the product and reactant is we have to take here the values for cathode and values for a anode. Already we know that E cell and E0 cell. Then the next formula is Colratch's law. So lambda naught m is equal to lambda naught cation plus lambda naught anion. Then degree of dissociation. For the degree of dissociation we have to use alpha is equal to lambda m divided by lambda naught m. So lambda m is molar conductance at a concentration C. Then lambda naught m is a molar conductance at infinite dilution. So dissociation constant. Okay, Ka itself is a dissociation constant, alpha square C divided by 1 minus alpha. Already we know that alpha is a degree of dissociation. So now let us solve some problems on these formulas. Okay, the first one is represent the cell in which the following reaction takes place. So here the reaction is, and we have to calculate its E cell if E0 cell is equal to 3.17 volt. Here the E0 cell is given and they have given the values for anode and cathode. First we have to represent the cell. So that is so here we know that the single vertical line which is represents the electrode between a metal and a electrolyte solution, and here the double vertical line indicates the salt bridge between the two electrode, and here this is also a single vertical line which indicates the electrode between the metal and the electrolyte. Okay, here we have to use the formula E cell is equal to E0 cell minus 0.059 divided by 2 into a log of Mg2 plus divided by Ag plus 2. So here this is oxidation, means we know that the oxidation occurs at the anode side and the reduction occurs at a cathode side. So here we have to put the values. the E0 cell is value is given, that is 3.17 volt minus 0.059 divided by 2. Then a log of value for Mg2 plus is given, okay, that is 0.130 to the 0.0001. Okay, so we have to simplify this. Here we know that log of A by B, we can write it as log A plus log B. Here first we have to simplify this one. You will get log of 1.3 into 10 raised to 7. Then 3.17, 0.059 divided by 2. So here we can take log A into B is a log A plus log B. So log 1.3 into log of 10 raised to 7. Again we can take it as log of A raised to B is B into log of A. So after simplifying and calculating, you will get the value. So here I will directly write the value 2.960 volt. Okay, the next one is calculate the standard Gibbs energy for the reaction at a 298 Kelvin. Okay, here they have given E0 Zn2 plus bar Zn is equal to minus 0.76 volt. E0 Ag plus bar Ag is equal to 0.80 volt, and we know the Faraday's value. Okay, these are given things. Here we have to write the standard EMF of a cell. E0 cell is equal to E0 cathode minus E0 anode. Okay, this is simple, and we have to directly substitute the values for cathode and anode, that is 0.80 minus and minus of 0.76. So here we get a E0 cell is equal to 1.56 volt. So but here we have to calculate the standard Gibbs free energy, and we know the formula delta G0 is equal to minus NF into E0 cell. Okay, minus 2 into, we know the Faraday's value, they have given 96,500, okay, into E0 cell, that is 1.56. Okay, after calculating you will get 523.03 kilojoule. Okay, come to the next problem. The conductivity of 0.01 mole per liter acetic acid is 4.95 into 10 raised to minus 5 Simon per centimeter. Calculate its degree of dissociation lambda naught m for acetic acid is 390.5 Simon centimeter square per mole. Here the given things are, they have given a concentration that is C is equal to 0.001 mole per liter, and the conductance K is equal to 4.95 into 10 raised to minus 5 Simon per centimeter. So now we know the formula. Lambda m is equal to K into 1000 divided by C, because for calculating a degree of dissociation we know the formula alpha is equal to lambda m divided by lambda naught m. Here only they have given lambda naught m value, but we have to calculate lambda m first. So that I am applying the formula K into 1000 divided by C. So here they have given lambda m is equal to K is 4.95 into 10 raised to minus 5. Okay, then into 1000 divided by C, the concentration 0.001. Okay, after calculating you will get lambda m is equal to 49.5 Simon centimeter square per mole. So we have found the value. Now substitute alpha is equal to 49.5 divided by, and already they have given lambda naught m 390.5. Okay, you will get alpha is equal to 0.126. Okay, this is what a degree of dissociation. Okay, sometimes they can ask directly, or you have to apply some simple formula like this. Okay, the next problem is lambda naught m for NaCl, HCl, sodium acetate or 126.4 Simon centimeter square per mole, 425.9 Simon centimeter square per mole, and 91.0 Simon centimeter square per mole respectively. Calculate lambda naught m for acetic acid. Okay, simple. Here we have to apply the Coleridge's law. The given things are lambda naught for a sodium acetate, the value is 91. Then lambda naught for HCl, they have given 425.9. then lambda naught for NaCl is 126.4. Okay, now according to Coleridge's law, lambda naught for acetic acid is equal to lambda naught for sodium acetate plus lambda naught HCl minus lambda naught for NaCl. Okay, now directly substitute the values. 91 plus 425.9 minus 126.4. After calculating you will get 390.5 Simon centimeter square per mole. Hope you understand the very important problems asked for your board exams. Hope you understand. Thank you for watching.